Hello everyone. Today we will discuss the Clemmensen reduction. So what is this Clemmensen reduction? It is the reduction of carbonyl compounds in acidic conditions. So first thing is it is the reduction of carbonyl compounds like aldehydes and ketones. Reduction of carbonyl compounds in acidic medium. So condition used in Clemmensen reduction is zinc amalgam with hydrochloric acid HCl. So this is the condition of a Clemmensen reduction, and in this reduction carbonyl compounds they are directly reduced to their corresponding alkanes in one step. So conversion of carbonyl compounds directly into alkanes in one step, that is a Clemmensen reduction. So in carbonyl compounds we have carbonyl bond. This bond is present in aldehyde as well as a ketone. If both alkyl groups are there, that will be ketone, and if there is one hydrogen and one alkyl group, that is a aldehyde. So by using zinc amalgam with the HCl, we can understand it with a short trick also. The role of HCl is to provide hydrogen ion. It will give H positive. So total we need 4 nascent hydrogen or 4 hydrogens. This double bonded oxygen will be removed and 2 valency will be free, 2 hydrogen will be added. So total we need 4 hydrogens. So we will require 4 moles of HCl, and we will obtain a alkane. So conversion of carbonyl compounds in acidic medium directly to the corresponding alkanes, that is called Clemmensen reduction. This is the trick to understand the reaction, and the quite importance of this reaction is it is a one step conversion of carbonyl compounds to corresponding alkanes. But what is the mechanism? Let us understand the mechanism. So this is again carbonyl structure. If we understand the bonding, oxygen is more electronegative, so carbon is having partial positive charge. So first comes into play the action of zinc. As we know, zinc is a metal and it loses its 2 electron to form its cation. So it give Zn plus 2 plus 2 electrons. It gives its 2 electrons, and as a result zinc form its cation. Now these 2 electrons shift to this carbon. As a result, oxygen also withdraw its electron. So the structure obtained is there is a negative charge on oxygen and negative charge on carbon. By the shifting of these 2 electrons, carbon becomes now carbanion. Carbanions means negative charge on carbon, and oxygen withdraws its electrons, so negative charge on oxygen also. So in first step we obtain this structure, right? Now we have the acidic medium HCl. It comes into play. Actually 2 HCl molecules will come and they will give 2 hydrogen, one to this carbon ion and one to this oxygen negative. So we will obtain the structure. Now negative charge of carbon and negative charge of oxygen is vanish out. So 2 hydrogen will come from this 2 HCl. 1 hydrogen to this, 1 hydrogen to this carbon. Now carbon ion becomes neutral, normal carbon is there, right? Next we have water molecule, or we have HCl. We have a acid again. So oxygen has a lone pair and hydrogen will give proton. So protonation of this oxygen takes place. Oxygen will give its lone pair to this hydrogen. As a result, this structure will form. Now we can say there is a formation of a water. There is a negative charge on a more electronegative atom, so it will withdraw its electron from this bond, resulting into the water molecules will be eliminated, and carbon will acquire now positive charge. So again we have the formation of a carbocation. Before we have a carbanion, and now we have a, here we have carbanion, now we have a carbocation. So now again zinc metal will come into play. It will give its electron again. So these two electron will make it again carbanion. Now we can see there is a formation of a alkane. Now we have again acid HCl. It will give proton. So now finally we have this structure. So this is our final alkane. So that is the real mechanism of a Clemmensen reduction. We can count total. We require 4 moles of HCl, 2 mole, 1 mole, and last here 1 mole. As we have discussed in a trick, 4 moles of HCl required, and we can see in a real mechanism there are 4 HCl are required. So reduction of carbonyl compounds in acidic medium, that is called Clemmensen reduction. I hope you would understand it. In CBSE there is a direct question: convert propanone to propane. You can use a Clemmensen reduction. You don't need to explain the mechanism. You can simply solve with the trick. Again, finally we are using trick again. That is the trick to understand a Clemmensen reduction. We totally need a 4 nascent hydrogen, means 4 mole of acids are required. That is a Clemmensen reduction. In next segment we will discuss the reduction in basic medium. That will be our Wolff-Kishner reduction. In acidic medium, reduction is Clemmensen. This is our Clemmensen, but in next segment we will discuss reduction in basic medium. That will be Wolff-Kishner reduction. Both are important for CBSE as well as competitive exams. We will discuss it in next segment. Thank you.